Dear students, let's continue with chapter 1 and exercise 1.1. Now we will do question number 2. Show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5 where q is some integer. Students, now this is a theoretical question and mostly students cramming ਕਰਨ ਦੀ try ਕਰਦੇ but let's do it in a practical way so that ਤੁਹਾਨੂੰ ਇਹ properly understand ਹੋ ਜਾਵੇ. Now considering the equation, we have to represent the numbers in the form of 6q plus 1, 6q plus 3, 6q plus 5. अगर आप ध्यान दिए then these numbers are of the form a is equals to bq plus r. This is the right side and here the value of b is 6. This is the formula of Euclid division algorithm. That means we have to apply the steps on the numbers. Let's do it practically. Let positive odd integers be 1, 3, 5, 7, 9, 11, 13, 15 and so on. Now, according to our previous questions, we have to divide these numbers by 6. That is like this. And so. Now the question arises here is how we can divide 1 by 6, 3 by 6 or 5 by 6. These are the smaller numbers than the divisors. Hopefully ਤੁਹਾਨੂੰ याद होगा छोटी क्लासेस ਦੇ ਵਿੱਚ ਆਪਾਂ ਡਿਵੀਜ਼ਨ ਕਰਦੇ ਹੁੰਦੇ ਸੀ ਜਦੋਂ ਸਾਡਾ ਡਿਵੀਡੈਂਡ ਡਿਵਾਈਜ਼ਰ ਤੋਂ ਛੋਟਾ ਹੁੰਦਾ ਸੀ ਤਾਂ ਅਸੀਂ ਨਾ ਜਾਣ ਦੀ 0 ਲਗਾਉਂਦੇ ਸੀ same step we have to follow here 1 6 ਤੋਂ ਛੋਟਾ ਆ ਨਾ ਜਾਣ ਦੀ 0 remainder is 1 same for 3 for 5 then again 7 is greater than 6. Similarly you can continue for another numbers. Now represent these numbers in form of this. 1 can be written as 1 is equals to 6 into 0 plus 1. 3 is 6 into 0 plus 3. 5 is 6 into 0 plus 5. Next 7 is 6 into 1 plus 1. 9 is 6 into 1 plus 3. 11 is 6 into 1 plus 5. 13 is 6 into 2 plus 1. 15 is 6 into 2 plus 3. 17 is 6 into 2 plus 5. Now look at these equations. These are of the form, this is 6q plus 1. This is 6q plus 3. This is 6q plus 5. Here the number q varies. Now we have taken different odd integers and proved that these all can be represented either in the form of 6q plus 1 or 6q plus 3 or 6q plus 5. Hence we proved that every positive odd integer can be written in the form of 6q plus 1, 6q plus 3 or 6q plus 5. That's it. Let's continue with exercise 1.1 of chapter 1 real numbers and question number 3, that is 616 army members to march behind an army band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Now, what is the question? Question is, we have to find the maximum number of columns in which they can march. Maximum is here refers to HCF. HCF means highest common factor. It means once again we have to find HCF of numbers 616 and 32. Again proceeding the same steps. 616 is the greatest term. It will be divided by 32. Let's divide it. 31, 32 ones are 32 and the remainder is 29. Then there is 6 and then again it will be this 8. Now 32 will be divided by 8. 8 4s are 32 and we got remainder 0. Now proceeding with Euclid's division algorithm, we have find A is equals to BQ plus R, where our A is 616, B is 32, Q is 19 and R is 8. Proceeding to next step, A is 32, B is 8, R is 4, Q is 4 and R is 0. Here we get 0 as remainder, so our process stops here. We got the HCF of the numbers 616 and 32, that is this 8. This is our answer. It means number of columns is 8.